vertically projected motion of vertically projected. This will be motion of vertically projected body. Yeah, no. We have to describe the, so let me take this as a ground. Here I'm going to project a stone. Let me take a stone or a ball. I'm going to project with a velocity u. This is at t equal to 0. I'll project with a velocity u from the ground. You just take some stone and project and throw it vertically up, or throw a ball. So what can be this ball? Okay, this object, it can be ball or a stone. Then what is the type of motion it's going to describe? As it's going to describe an retarding motion. The stone is going to ascend, and for a while it will come to instantaneous rest here. Then again it's going to descend back. Then what is the velocity? How to calculate the motion of this? So let the velocity be v. The weight mg will act. Then the force is acting opposite to the motion. So this will be retardation. Let's calculate that retardation. So this retardation A is equal to minus mg by m. Why that negative sign? Because that force is acting opposite to direction of motion. So it will undergo retarding motion. So therefore this will become minus g. So what are the equations of motion? It will be now v equal to u plus at, u minus gt. What about height ascended? At any time t, let height ascended h equal to ut minus gt square. So what is the first equation? The velocity of object at any time t. Height ascended by object for time t. Okay, after certain time t, at what height it will be, these are equations. So what is the type of motion it will describe again? So it will be retarding motion. So shall we put this a retarding motion? Or deceleration, and how much deceleration? Equal to g, equal to acceleration due to gravity. So what we have to do, again, we have to study this particular motion in vertically projected body. So what is the maximum height it will ascend? And what is the time of ascent? Okay, this will become the maximum height ascended. Then this will be time of ascent. So maximum height ascended. So we'll apply the equations of motion. Final velocity, here it is 0. And what about the object? Instantaneous rest here. Instantaneous. For a moment, it will come to rest here. Again, it will fall back. So at highest point, it will be at for a fraction of time, it will be at rest. So I'll just call that as instantaneous rest here. So now we'll apply the formula 0 square minus u square equal to 2 minus g into plus h max. These are some very, very important. The sign for in the formula v square minus u square equal to 2ah. The sign for VAH depends on you. If the quantities are directed opposite to initial velocity, should be taken negative. How the G will be directed vertically down. Acceleration due to gravity will be directed vertically down. So why negative sign? Because the acceleration due to gravity is opposite to initial velocity. Final velocity is 0, no doubt. What about the height ascended? It is measured in the direction of displacement, so therefore it is positive. So when you are using these equations of motion, what you should do? you have to use the sign convention. What is the sign convention? Like a final velocity, acceleration, and displacement. If they're measured in the direction of initial velocity, positive. They're measured opposite to that, should be negative. So look at the displacement, how we measure in the direction of initial velocity. So therefore it's positive here. So what is the convention? What convention says? V, A, and H. I'll write it. The convention V, A, and H are taken positive, are given positive, so are taken positive if they are measured along initial velocity u, or if they're measured or directed, if they're directed or measured along initial velocity u. Measured or directed, and anything. Let me just put this slight change, I'll make it. V, A, H are taken negative if they are measured, directed opposite to initial velocity. Let me put it in proper place. Yeah. Okay, this is a very fundamental thing which we will be taking help of in our discussion. I'll correct it, spelling initial velocity. This is okay. I can just highlight only this much. Leave it here. Okay, fine. This is about the convention. So are you getting reason why G negative? Because it's measured opposite to initial velocity. Why H max positive? Because it measures in the direction of initial velocity. So solving this will end up. So what is the maximum height ascended? Maximum height ascended by the body is equal to H max equal to U square by 2G. Whatever time of ascent, how to calculate? So the time of ascent again will calculate like this: 0 equal to U minus G. So time of ascent is equal to U by G. Let's describe the overall motion, how it takes place.